The Mohr circle basically used to calculate the absolute value of the shear stress or the maximum possible value of the shear stress, that is called as overall shear stress or absolute shear stress. For this purpose, you have to convert the 2D stress into 3D stress, and you have to construct three Mohr circle using sigma 1, sigma 2, sigma 2, sigma 3 and sigma 1, sigma 3. Now sigma 1, sigma 2 and sigma 3 are the three principal stresses. Out of sigma 1, sigma 2, sigma 2, sigma 3 and sigma 1, sigma 3, you can have three different Mohr circles, and each of them has a different value of tau max. One value we obtain from the given state of a stress, that will be the principal stress for this given state of a stress, let's say equal to sigma A, sigma B, and then you have to arrange the value of sigma 1, sigma 2, sigma 3 in such a fashion that the value of sigma 1 will be always greater than equal to sigma 2 is always greater than sigma 3. If the two-dimensional state of a stress has stress along the x-axis is sigma x, shear stress equal to tau xy, and along the y-axis is sigma y, then you can calculate here the two principal stress which we labeled as sigma A and sigma B. So when the value of sigma x and sigma y and tau xy is known, then we are able to calculate the principal stress using the same formula that we are familiar. Sigma A or sigma B can be obtained as sigma x plus sigma y divided by 2. We have plus minus under root of sigma x minus sigma y divided by 2 whole thing square plus we have tau x y square. Now when you solve this equation, depending upon the value of sigma x, sigma y and the tau xy, the value of sigma A, sigma B can be both value positive, or one value is positive and other value is negative, or both value will be negative. All possible chances are there depending upon what is the state of a stress we have given you in the two-dimensional. So one value of this, which one is the largest value, you have to assign as sigma 1. Other value you have to assign to sigma 2, and to convert the two-dimensional into three-dimensional, whatever the value is left, then you have to assign that value equal to 0 for the third principal stress. So how to select the value of sigma 1, sigma 2, sigma 3? For this one, I will take the three cases here. I want to make here two terms very clear. One is the value that is called as in-plane maximum shear. So whenever we have given the two-dimensional state of a stress, then we can calculate the value of tau max. That is the maximum in-plane shear will be equal to, the two principal stresses are sigma and sigma B. So we can calculate this value as absolute value of sigma A minus sigma B divided by 2. So whether A is greater, B is greater, it doesn't matter, and we can take the absolute sign and we can assign in plane maximum shear equal to positive value. Or we can use the value of tau max as equals to this under root sign, which is equal to under root of, we have sigma x minus sigma y divided by 2, and we have whole thing square plus we have tau x y square. So whatever the value you calculate using the given two-dimensional state of a stress, that will be called as tau max, and this value of tau max hereafter we'll call it as in-plane maximum shear, which can be obtained by simply the two principal stresses, one is sigma A and sigma B. Now depending upon the value of sigma A and sigma B, you have to arrange the value as sigma 1, sigma 2, sigma 3. In this case, the sigma 1 is the largest value and sigma 3 is the lowest value. So naturally in this case, the Mohr circle obtained by sigma 1 and sigma 3 will be the largest Mohr circle, that is having the highest value of diameter. In that case, the value of overall maximum shear or absolute maximum shear will be defined as tau absolute is maximum value is given as modulus of sigma 1 minus sigma 3 divided by 2. So this one is a universal definition that I am going to use. For this purpose, we have to arrange the order as sigma 1 is greater than equal to sigma 2 is greater than equal to sigma 3. To get this concept clear and to have a clear distinction between the in-plane maximum shear and the overall or the absolute shear stress, that is the value of tau max and tau absolute maximum, we'll discuss here the three cases. And we'll see here how to assign the value of sigma 1, sigma 2, sigma 3 to sigma A and sigma B. That is, here we are converting the two-dimensional state of a stress into three-dimensional state of a stress. Now case 1 we'll discuss first here. In this case, suppose we have get the value of sigma A and sigma B. Both are positive value and sigma A is greater than sigma B. So highest value in the first case I will take the value of sigma A is greater than equal to value of sigma B. Since here sigma A and greater than sigma B, and let assume that both values are positive value. Now according to this sequence, sigma A is the highest value, sigma B is the second value, and sigma 3 is the lowest value. So we have to follow this same sequence here, that is we have sigma 1 will be assigned is equal to sigma A. Sigma 2 will assign the value of sigma B. So in this fashion we have got two-dimensional state of a stress, and now we want to convert into three-dimensional, and one principal stress is left is sigma 3. So we'll assign the value of sigma 3 is equal to 0. Using sigma 1, sigma 2, sigma 2, sigma 3, sigma 1, sigma 3, I will construct here the three different Mohr circle, and we'll find out here what is the difference between in-plane maximum shear and the overall maximum absolute shear. Let's say we have example here, we have sigma A is equal to 70, we have sigma B is equal to 20. So 70 is higher as compared to 20, so our sequence is correct. And the least value in this case you have to assign the sigma 3, that equal to 0. Sigma A is same as sigma 1, sigma B is same as equal to sigma 2, and sigma 3 will be equal to 0. This is just an example I am giving you where both the value of principal stress for the given state of a stress are positive. So to draw the Mohr circle here, we'll use the coordinate system as sigma and the tau, and we'll locate here the three principal stresses. In this case the sigma 1 is the highest value, so I will mark the sigma 1 somewhere here. Sigma 2 is the intermediate value, so somewhere here I will mark the value of sigma 2. And we have assigned the value of sigma 3 equal to 0. So this time we have sigma 3, that is the third principal stress, equal to 0. So we'll draw here one Mohr circle which is passing through sigma 1 and sigma 2. So this one is the Mohr circle is constructed using sigma 1 and sigma 2. This point here will represent the in-plane maximum shear, that is the value of tau max, which one is same as sigma A minus sigma B divided by 2. So this value will be called as tau max, which one is the in-plane maximum shear. One more circle will construct for sigma 2 and sigma 3. So this Mohr circle is drawn with the principal stress equal to sigma 2 and sigma 3. And one more circle will draw using sigma 1 and sigma 3. So that will always give you the largest diameter, and hence it is called as the overall maximum or the absolute shear stress. So when we fix up our order of sigma 1 greater than sigma 2 greater than sigma 3, then we always get this Mohr circle, which one is having a largest radius. So this Mohr circle is say drawn using sigma 1 and sigma 3. And the radius of this Mohr circle, which one is sigma 1 and sigma 3, will be equal to overall maximum shear or absolute shear, will be written as tau absolute and the maximum value. So in this case we have a different value of tau max and different value of tau absolute maximum. As far as the maximum shear is considered, we have given here the two-dimensional state of stress. So your first job is to calculate the two principal stress, then assign the value of sigma A, sigma B to sigma 1, sigma 2, sigma 3, and you have to follow this sequence strictly, and then you have to construct the Mohr circle and you have to obtain the value of tau absolute maximum and the tau max. So in this case the overall maximum shear stress, that is the absolute value of the shear, is greater than in plane maximum shear. So this concept we required in the case of maximum shear stress theory. And since here we have value of sigma 1 is same as equal to sigma A, sigma 3 is equal to 0, so we can have the value of tau absolute maximum will be equal to sigma 1 minus sigma 3 divided by 2. That will be equal to sigma 1, which is same as equal to sigma A. Sigma 3 will be same as equal to 0 divided by 2. So this value is same as sigma A divided by 2. Likewise, we'll discuss the second case and the third case, and we'll try to make here the clear distinction between in-plane maximum shear and the overall maximum or the absolute shear stress. Now we'll take the case 2, in which suppose I say that I get the value of sigma A is equal to 70, sigma B is equal to minus 30. That is, for the given state of a stress, one value of the principal stress is a positive value and one stress will be negative value. So this situation is same situation where we have value of sigma A, that is a principal stress for the given two-dimensional state of a stress is a positive value, that is greater than 0. And this value is negative, so this is less than 0. So we'll write 0 is greater than sigma B. Since here the highest value is sigma A, then that will be equal to sigma 1. So in this case, we have sigma 1 is same as equal to sigma A. Sigma 2 will be equal to 0 and sigma 3 will be equal to sigma B. So by this example, this idea is very clear. Always sigma 3 is not equal to 0. You have to assign the sigma A and sigma B as the sigma 1 is the highest value and sigma 3 is the lowest value. Out of 70 and minus 30, 70 is the highest and minus 30 is the lowest. So let's construct here the three different Mohr circle using sigma 1, sigma 2, sigma 2, sigma 3 and sigma 1, sigma 3. This time we have sigma 1 is same as equal to sigma A and is a positive value. So we'll mark this value somewhere here, and this value is same as sigma 1 is equal to sigma A. Sigma 2 is equal to 0. So we have to mark the value of sigma 2 equal to 0. And sigma 3 is equal to sigma B. So this value is same as sigma 3 is equal to sigma B. And we have to show this value on the left hand side. So in this case, the first Mohr circle will draw for sigma 1 and sigma 2. So if you draw a Mohr circle, it will be like this. So the first Mohr circle is passing through sigma 1 and sigma 2. Then one more circle we can draw for sigma 2 and sigma 3. So this one is the second Mohr circle which is passing through sigma 2 and sigma 3, and one more circle you have to draw with sigma 1 and sigma 3. That will be the largest possible Mohr circle. So this largest Mohr circle is formed using the sigma 1 and sigma 3. Since our order is fixed, you always get the maximum value of the Mohr circle with sigma 1 and sigma 3. Only thing that you have to adjust your value such that the sigma 1 is always greater than sigma 2, always greater than sigma 3. Sigma 1 can be sigma A or sigma 2 can be sigma A. So this adjustment you do depending upon the numerical value. And the radius maximum value of the shear stress. So if I draw here a tangent, I will get this value, that is the tangent to this circle will be same as equal to tau max. This circle is basically sigma A and sigma B, and the same value is also equal to absolute value of the shear stress, because sigma A is same as sigma 1 and sigma 3 is same as equal to sigma B. So this one is a special case in which the in-plane maximum shear is same as the overall value of the shear stress. So in this case we have tau max, that is the value of in-plane maximum shear is same as equal to the overall maximum shear, which we write as T absolute maximum. In-plane maximum shear is given as sigma A minus sigma B divided by 2, whereas absolute value will be given as sigma 1 minus sigma 3 divided by 2. And this time we have sigma 1 is same as equal to sigma A and sigma 3 is equal to sigma B. So this one is a special case in which if one value is positive and one value is negative, then the in-plane maximum shear is same as equal to the absolute shear stress. Now we'll take here the case 3, in which the principal stresses obtained for the given two-dimensional state of a stress sigma A and sigma B both are negative. Say for example, we have sigma A is equal to minus 70, sigma B is equal to minus 30, That is the value of sigma A and sigma B both are less than 0. So 0 is greater than equal to the value of sigma B. Out of sigma and sigma B is a higher value, is greater than sigma A. And we want to compare this sequence with sigma 1 greater than equal to sigma 2 greater than equal to sigma 3. Then we have to assign the value of sigma 1 is equal to 0, sigma 2 is equal to sigma B, and sigma 3 will be equal to sigma A. Now sigma A and sigma B both are negative, so Mohr circle will be considered on the left hand side here. So we'll start with sigma 1 first. So this value will be equal to sigma 1, that equal to 0. Then we'll show sigma 2, which is equal to sigma B is minus 30. So somewhere we have sigma 2, which is same as equal to sigma B. And then we'll show one value with sigma 3. So we have sigma 3 is equal to sigma A. Again we'll construct here the three Mohr circle using sigma 1, sigma 2, sigma 2, sigma 3 and sigma 1, sigma 3. So sigma 1 and sigma 2, the Mohr circle passing through sigma 1, sigma 2 will be somewhat like this. So this Mohr circle is drawn for sigma 1 and sigma 2. Then one more circle will draw for sigma 2 and sigma 3. It will be touching sigma 2 and sigma 3. So this Mohr circle is drawn for sigma 2 and sigma 3. That is for sigma A and sigma B. So naturally here, if I measure the radius of this Mohr circle, that is the value of tau max in case of plane of maximum shear. So this value corresponds here the value of tau max, which is equal to the plane maximum shear, in plane maximum shear. And the largest possible Mohr circle is fixed, that is sigma 1 and sigma 3, sigma 1 and sigma 3. So you have to draw here one more Mohr circle. So this one is the third Mohr circle we have drawn with sigma 1 and sigma 3. And if you measure the radius of this, that is by drawing the tangent to this one, and you can measure the maximum value. But this one is called as overall maximum shear, or is represented by T absolute maximum value, that is the absolute shear stress. So T absolute maximum shear is normally greater than equal to in plane maximum shear. So in this case we have T absolute shear stress is greater than the in plane maximum shear. So these are the three situations that arises in the case of principal stresses in case of two-dimensional state of a stress. The first case we have taken that sigma A is greater than sigma B greater than 0, that is both the principal stress for the given two-dimensional state of a stress are positive. Then the absolute shear stress is greater than in plane maximum shear. In case 2, if sigma A is greater than 0, that is a positive value, and sigma B is a negative value, Mohr circle will lie on both sides. And this time it's a special case, that is the in plane maximum shear is same as the absolute shear stress. And in the third case, if both the value of sigma A and sigma B are negative, in that case the entire Mohr circle will lie on the left hand side, and this case we have the absolute shear stress will be greater than in plane maximum shear. So basically we are not interested in plane maximum shear, rather we are interested in the overall maximum or absolute shear stress. To find out the value of overall maximum or absolute shear stress, your first job is to calculate the value of sigma A and sigma B from the known state of a stress using the equation sigma x plus sigma y divided by 2 plus minus under root of sigma x minus sigma y by 2 whole square plus tau xy square. Once you get the value of sigma A, sigma B, like in case 1, case 2, case 3, then arrange them in the standard form of sigma 1 greater than equal to sigma 2 greater than equal to sigma 3. Say for first case we have sigma A and sigma B both are positive and sigma A is greater than sigma B. So highest value in this case will be sigma 1, and the least value is 0. So we have sigma 1 is sigma A, sigma 2 will be equal to sigma B, and sigma 3 equal to 0. So we can very well calculate here overall maximum shear, that is the absolute maximum shear, equal to is a sigma 1 minus sigma 3 by 2. Sigma 1 is equal to sigma A minus sigma 3 equal to 0 divided by 2. That will be same as equal to sigma A divided by 2. In the second case, we have sigma A is greater than 0, that is positive, and sigma B is less than 0, means negative. In that case, again we have to use the same equation. Sigma A is the highest value, so sigma 1 will be equal to sigma A, lowest value is sigma B, and between the positive and negative, one value you have to take is always equal to 0. So sigma 2 will assign equal to 0, and sigma 3 will be equal to sigma B. In this case, the overall maximum or absolute shear stress, that is tau absolute maximum value, will be equal to sigma 1 minus sigma 3. Sigma 1 is equal to sigma A minus sigma 3 will be equal to sigma B is divided by 2. And in the third case, if both are negative and we have sigma A is the least value as compared to sigma B, then we have 0 greater than sigma B greater than sigma A. So highest value here is 0, that will assign as equal to sigma 1. The least value is equal to sigma 3, that equal to sigma A. In this case, we have the overall maximum shear stress or absolute maximum shear stress will be equal to sigma 1, that equal to 0, minus sigma 3, that equal to sigma A divided by 2. That is same as minus sigma A by 2. For calculation purpose, you have to always take the positive value. So this one is the three cases that you to study for overall maximum shear and the absolute maximum shear. So there is a difference between in-plane maximum shear and the overall maximum shear. So whenever you have to solve any problem for theory of failure and you are given the two-dimensional state of stress, you have to always convert into three-dimensional state of stress. And using the three Mohr circle, we have to always find out what is the value of overall maximum or absolute shear stress. So for case 1 and case 3, we have different value. But in this case, that is in case 2, if one is positive and one is negative, then in-plane maximum shear will be same as the overall maximum or absolute shear stress. I hope the concept is clear. And one last concept we required is the maximum shear stress that can be obtained by using a tension test. For this one, we have to consider a dog bone shaped tensile specimen and is subjected to tensile force is equal to F. So the maximum shearing stress generated during the tensile testing when these dog bone shaped tensile specimen are subjected to tensile testing to obtain the stress strain curve. Initially, the stress is proportional to strain up to the yield point. So this point here is called as yield point. And then the necking is start. That is, a permanent deformation will start. So this value is represented as SY. That is the yield strength. If the force F is further increased, then we'll get a fracture at certain point. This fracture will occur on a plane at an angle of 45 degree with the vertical. So these are the straight lines where we have obtained the value of fracture. This angle is almost equal to 45 degree. So these lines are called as the strip lines where the fracture will occur. So before the yield and the fracture of this specimen will happen in a slanted planes that have a 45 degree angle and commonly known as the strip lines. At a given state, we are stressing it along the y direction. So stress acting on the y face will be equal to the tensile stress equal to sigma y. As such, there is no shear stress is formed here. So for x face, which one has a coordinate of sigma x and tau xy, both value will be equal to 0. So we have x coordinate, that is the x face coordinate will be 0, 0. Whereas the y face has again the coordinate equal to sigma y, tau xy. So on y face we have sigma y and tau xy is 0. we can locate the x phase and y phase on the normal stress and the shear stress axis, and we can draw the Mohr circle. As far as the coordinate of the x phase considered are 0, 0, y phase considered is sigma y comma 0. This one is representing the normal stress. The vertical axis will represent here the shear stress, and this value of shear stress is clockwise is taken as positive and anti-clockwise is taken as negative. But as such, there is no shear stress on both x and y phase. X phase we can locate at origin. So this one is x phase coordinate. So this one is y phase, where we have a value of sigma y only and the value of tau xy is 0. So using x and y, we can draw here a complete circle that will be the Mohr circle. At yield point here, we have corresponding value of sigma y will be same as equal to yield strength, that is equal to Sy in tension is equal to T. So yield strength means that the sigma will reach the yield strength, so that the yield strength value is equal to Syt. But we are interested in the maximum shear stress in a tension test, and the maximum shear stress we can obtain as a radius of the Mohr circle. So this value corresponds to Sys, and this value of Sys is same as equal to diameter. So this one is same as equal to diameter, which is equal to Syt, and Sys is a radius. So in this case we have Sys. Sys means the maximum shear stress induced at the given moment, that is at the yield point, will be same as equal to diameter divided by 2. Diameter is same as equal to Syt, so we have Sys. In a standard tension test, that is the yield stress in shear will be taken as Syt divided by 2. So anytime you want to know the material property Sys, then you can use the relation Sys is equal to Syt divided by 2, which one is nothing but the radius of the Mohr circle. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.